This is a subset of an overall video series helping you master the cut quality on your machine. This particular sub video is going to be just a very basic overview of the laser parameters. But if you're interested in the full video series, check it out on my website at ramseycustoms.com. All right, guys, continuing on with the series here, we're now going to take a look at the layer parameters and go through the details of this one by one to explain what it is that we're looking at. So the first thing is the very top section here. We're going to look at these in detail and just do a quick explanation and then move on to the next section. Okay, short move. If you have that selected, you can specify a distance. So from one feature within a part to the next, if that distance is less than a variable that you set, it will not lift the head. So basically this really has nothing to do with cut quality and everything to do with making your machine run as fast as it can in a production mode. So we're not going to really talk about that too much because this is kind of like mastering the cut and the cut quality. Pre-pierce will have something to do with cut quality. That if you have that selected, it's going to go around and pierce all of the holes first and then come back and cut the holes. And that can serve as a way to cool the part or let it cool a little bit between the pierce routine and the cut part of the job. So that's one that you'll use pretty frequently. Evaporation of film, again, you know, if you've cut in stainless or aluminum that's got a film on it, it'll run around and evaporate the film layer with a very light kiss cut and then come back and do the actual cut. All right, so the next thing we want to look at is path cool. What that does, again, it's something heat related, but it's an after the fact thing. So if you have that checked, when it actually cuts the part, it will recut the part, but with the laser off. And that will serve as a way to cool the part down so you can touch it after the cut. Not really anything we're going to be interested in here as far as helping with cut quality. The next one is keep puffing. That is something that you may be interested in when cutting thick material to help you keep the parts cool. You'll notice the trend here of, you know, that any oxygen cutting when thick material, keeping the part cool is extremely important to cut quality. So keep puffing means that between the moves, you know, the rapids from one part to the other, the gas stays on all the time. So, you know, could be a cost to that, but in the end, it may save you with the increased quality of the parts. All right, so next we're gonna move down to this part of the screen and take a look at these options here. These are something that you may wanna use, again, in thicker material. You're almost never gonna use this in thin material, but if you check the slow lead, it lets you specify a length of the lead and specify a speed for it. So in other words, let's just say your cut speed is 30 inches a minute, and but for the beginning part of the lead, let's say your lead is 3 millimeters or 1/8 of an inch. So for the first 1.5 millimeter of that, or the first 100 thousandths of that, for example, you want to have that cut at half of the cut speed. Sometimes when you're piercing in thicker material, you know, the actual quality of the pierce can have some porosity in there, and when the cut starts, it can struggle a little bit with the very beginning part of the lead. And by doing the slow lead, it'll let it sort of work in there more smoothly. And the same thing with the stop. You know, if you have problems with the part falling out, you know, you may want to, as it approaches the stop, the last section of the cut, let's say the last, 2 millimeters or 60 thousandths roughly of the stop, you slow it down, give it a chance for the feature to drop out, the hole or whatever it is. All right, so next we're going to look at dynamic power adjust, and I'm not going to talk about this in much detail because we're going to show it in depth in the video series showing you how to dial in your cuts in thin material. In thicker material, it's less of an issue because you're overall moving the machine at a very slow speed. It's really when you're running the machine at a very high speed, cutting small details, that you want to use dynamic power adjust. That basically what it does is it basically says that, you know, if the machine is running at 70% of what its target is, that it's going to adjust the power by whatever percentage you want. So you might say if the machine's running at 70%, we want to run 50% power. And again, when you're cutting thin materials at a very high speed, when you're cutting in fine details, the machine's never going to run at its max speed anyway, and it's just a way to dial the power back to get burr-free cuts in thin material. It definitely helps. It's something you're going to want to use on a regular basis. And again, as we get into that section of the video series here, we're going to show that and show how to use it. All right, so now we're going to go through the main set of parameters that you want to set to dial in and set the speed of, you know, the overall parameters of the job that you're running here. So we're going to look at cut speed. Obviously, cut speed is going to be how fast the job is going to cut. And I'm going to try to mention here as we go through this the metric references to all these. So 450 inches a minute is about 11.5 meters per minute. And if you want to change how your speed or any of these parameters are displayed, if you go into the global parameters tab at the top, you'll be able to set the variables. So if you want it inches, millimeters, or meters, you know, all that is configurable in that global parameters part of this. All right, so the next one down is going to be lift height. And that basically is how far the head lifts between moves. So when it's rapiding between features or rapiding between parts, the Z or the head lifts up, you know, retracts up, moves, you know, and this normally will be somewhere between 0 and 2 inches or 0 and 200 millimeters, you know, somewhere in that range. All right, so next we're going to look at cut height, and this one definitely has a major impact on your cut quality and is a feature that, you know, you want to dial in. And so we'll take a look at that in more detail as we get through it. But you see the ranges there, 0.015 inches to 0.03 inches for thin material, or 0.4 millimeter to 0.8 millimeter in thin material. And then for thick material like carbon steel with oxygen cutting, you're going to be somewhere in the 0.03 to 0.06 inches or 0.8 millimeter to 1.5 millimeter. That will be the range for oxygen cutting in thick material. All right, next up we're going to look at the assist gas type and assist gas pressure. Again, these are going to be pretty straightforward. You know, if you're cutting with nitrogen, you want to make sure that's selected. If you're cutting with oxygen, you want to make sure that's selected. Most of the Chinese import machines do not let you set the pressure for nitrogen in the software. The air valve for that is only an on and off solenoid, where oxygen pressure requires a lot more finesse and fine tuning. So you actually, it is an air valve that not only has on and off, but also you'll see the secondary part of it if you look at the back of your machine, where it actually controls the pressure as well. And that's where you set that. Super critical, super important. We're going to talk about that and show you some things about that. You already saw the calibration part of that, where we looked at the actual pressure and how important it is to know where the range is on your particular machine. All right, so next up we're going to look at cut current, and this is going to be, you know, what laser power, or let's say peak laser power, that your machine is running at. So you see this one here, the field that you can select is the percentage, and the actual wattage is grayed out. So if you know, this is a 1,000 watt machine, 100% showing 1,000 watts. If you were to change that to 50%, it would show 500 watts. Same thing on 1,500, 3,000, whatever you got. This is primarily going to be set to 100% in all thin material, nitrogen, or compressed air cutting. And then once you get into carbon steel cutting, when you reach somewhere around the halfway point of your machine's max thickness, you're going to start to dial that power back, and dial it back between 100 and 75%, and that gives you your tuning range. And you'll see more about that in the cut charts, and when we get into the video a little bit later. But it's important. Makes a big difference in the cut quality in thicker material cutting with oxygen, carbon steel, when you reach the upper end of what your machine's capable of. All right, so the next one down that we're going to look at is going to be cut power. And I've also seen this on some versions of SIP cut labeled as duty cycle. And so lowering the duty cycle reduces the average power delivered while maintaining higher power pulses. So it'll maintain the peak pulses at, you know, whatever you set as your peak current that we talked about in the previous section, and but reduces the average across the pulses. So a little bit confusing. I can't say that I understand it completely, but I do know that this is a very useful tool when you're cutting small holes in thicker material. And you know, if you're cutting, you know, say a 6mm hole in 6mm thick steel with carbon steel with oxygen, that if you're having difficulty getting a clean hole, that this is a parameter that you can adjust, dial back a little bit, tweak it, see if it'll improve your results. All right, so next up we're going to look at cut frequency. And when we get into the piercing tab, which we're not going to do in this part of the video segment because we're going to have at least 2, if not 3 video segments dedicated to piercing, and we'll look at all those settings in great detail. But cut frequency and pierce frequency, you know, 2 different things. Pierce frequency is super critical. You'll find that cut frequency won't really change a lot. Like between the ranges of 1,000 and 5,000 hertz, you're not going to see a lot of difference. Occasionally in thicker material, you know, if you lower the cut frequency, like if you're trying to get a corner to smooth out, or, you know, things like that, you know, say from 1,000 down to 2,000 hertz, you can have a minor impact on the cut quality in thicker material with oxygen when you're you know, trying to cut a sharp corner or something like that. But in general, you're going to keep this set at 5,000 hertz. All right, so now we're going to move on down to the next section here. We're going to look at the beam size and cut focus. Beam size is going to be likely disabled and grayed out on most of your machines. I think there are some power sources, like some of the more advanced ones like Inlight and maybe some of the IPG, that do allow for beam shaping and you know, a parameter there that you could use, but more than likely that's going to be grayed out on your machine. The cut focus, super critical, very critical part of the parameters. Has a major impact on your cut quality, and as you saw in the calibration section of our video series here, that, you know, the ranges of your focus may not be what is standard or what is norm, and there is a method for finding the range, and we're going to show you that in detail as we get into the actual you know, on-site or hands-on part of the video series. And in fact, I probably will make a separate video just talking about focus and talking about, you know, how to find the range on it, because it's so critical and is confusing to people. So yeah, we'll talk about that in more detail. Okay, so the next section we're going to look at here is the very last section with the delays. So the first one, delay time, is right before your laser head starts to cut. You can specify a delay time here, and that's the time that the assist gas comes on first, and then the laser starts the cut process. And this is a pretty helpful thing to do if you're running into problems contaminating your lower lens. You know, you especially with oxygen cutting, in my experience, is that you want to run at least a 100 to 200 millisecond delay there with all oxygen cutting. With nitrogen cutting, I see it less important. And also, if you notice your machine appears to have a pause or a delay even when this is set to 0, there is a setting in the global parameters for this as well. So you can apply a global delay in global parameters, so no matter what you have set here, every parameter set is going to have an automatic delay in it. And then the last part of it is going to be laser off delay. And again, that's goes hand in hand with one of the ones we talked about earlier, where, you know, if you don't think your getting a full cut, your part's not dropping out like you want it to, you can turn that laser off delay on, and that's where it delays turning the laser off as it finishes the cut. So something you can experiment with that if you're having a problem with the part dropping out cleanly. Again, just a reminder, what you just watched is an excerpt from an overall video series that's going to have somewhere around 3-4 hours of total content helping you master your cut. If you want to get the full series, you want to go to ramseycustoms.com, and from this main page you want to scroll down to the laser consulting and training, and you'll see the options in there. I've got it bundled with a basic SIP cut tutorial to give you $100 savings, or if you want to buy this as a standalone, it's $3.99, or if you buy it with the bundle, it's $4.99.